Good afternoon. Now I am explaining the second experiment, that is viscosity determination of an organic liquid. Okay. So viscosity is a property of a liquid and it is the resistance offered by one part of the liquid over the other part. Okay. As we all know, liquid is made up of layers, and when the layers, in between the layers, there are many interactive forces between the layers. And if these layers, there are more, and that what interactions offer some resistance, they reduce the flow of liquid. Okay, the friction, as much the friction between the layers are less, the liquid flows more easily. Okay. So in this experiment we shall be finding out the viscosity of a given liquid by comparing it to a standard, and the standard chosen is water. Okay. So for this experiment we need to use the apparatus. First one is the Ostwald viscometer. We need a 10 ml pipette. We need a stop clock. We need the distilled water and whatever the solution or whatever the organic liquid of which we have to find out the viscosity. Okay. So the first part, what we do, the principle behind this experiment is we can find out the viscosity depending upon the time taken by the liquid to flow between two intervals. Okay. If there are more interaction between the layers, if there is more friction, the flow becomes slow. So the liquid takes more time to flow between the two points, two intervals. Depending on this, depending on the time taken by the liquid, we will analyze the viscosity of the given liquid. The first part is we shall be using a viscometer, and in this viscometer we will be taking some specified volume of the first liquid and then for water. Okay. So first I will be using a pipette to pipette out the organic liquid. Now I have taken 10 ml of organic liquid given to you in a dry pipette. I have transferred to the broader limb of the viscometer. Now there is 10 ml in this bulb. Okay. So the next is, my intention is to find out the time taken by this liquid to flow between these two marks. Now what I should do is, I shall be sucking up this liquid using this rubber tubing above this mark. Okay. And then when I leave the pressure, when the liquid level crosses this point, I will be starting the stop clock, and when the liquid level passes this point, I will be stopping the stop clock. Okay. That means I am measuring, or I am finding out the time required by this liquid to travel between these two intervals. See, now the liquid is crossing, stop. Now the liquid, when it crosses this point, I have started the stop clock. Now I am looking into the time when the liquid level crosses this point. There is another point here. Okay. So now the liquid has crossed this point and I have stopped the stop clock. Okay. So now if you see, it is 61 seconds. 1 minute 1 second, that is 61 seconds. Okay. So now I record, I will be recording. See here, experiment number 11 is determination of coefficient of viscosity of a liquid. In this, in the tabular column, see, time flow for the liquid in seconds. So here I will be writing 61 seconds. Okay. So now what I do is, again I suck the liquid, again note down the time. 3 times 3 trials I do. I will be taking the 3 readings of the 3 trials and I will be taking the average. Okay. So the next is, what I do is, this is for the organic liquid. Now I need to compare it to water. The standard taken is water. Okay. So now I need to tell how much, comparing to water, what is the rate of flow of this liquid. So I need to know the rate of time, time required by water also to flow between these two points. So next what I should do is, I should do the same experiment with water. Okay. So now when doing with water, now this organic liquid I have to take out, wash the viscometer properly, Okay, washing the viscometer has two steps. First is you have to wash it with water, but the organic liquid is just like oil. You cannot wash oil with water because they are immiscible. So what you have to do is you have to rinse it with acetone. Acetone is another organic liquid, but it dries very fast. Okay, so what you have to do is you have to wash with water and then you have to rinse with the acetone. Acetone will be given to you. After rinsing with acetone, along with the pipette also you should wash it with water and you have to rinse it with the acetone. Both you have to rinse it with acetone and then you have to keep it in the oven for complete drying. It will take around 10 to 15 minutes. After it is completely dry, you have to take out from the oven and you have to get it back to room temperature because the viscosity is dependent on temperature. Okay, whatever temperature you are recording the readings, the same temperature you have to take the readings for water also, because comparison can be done only at the same temperature. Along with that, the temperature affects the viscosity. As you all have seen, there are certain liquids. Let us take the example of road repair. They use the tar. It will be very thick because its viscosity is very high. But when you boil it, it flows easily. That means its viscosity reduces. That means as the temperature increases, viscosity decreases. That is because, as I said, there are a lot of interactions between the layers. There will be a lot of forces of attraction between the layers, and it is this forces of attraction which will increase the viscosity. That means it will hold the two layers, so it becomes difficult for the layers to glide over one another and flow. Okay, so when you increase the temperature, the interactions between the layers, the bonds break. When the bonds break, the liquid expands and there will be less friction, therefore the liquid flows easily. Okay, so for that reason, that means as temperature increases, viscosity decreases. Okay, so since temperature is affecting the viscosity, whenever we are comparing, we need to take the readings both at the same temperature. Okay, so therefore we need to record the lab temperature. Okay, so now I am recording the lab temperature. The lab temperature is 31 degrees. Now here there is an option for recording the lab temperature. The lab temperature shall be written here. Then here, as you know, we have recorded the time flow for the liquid in seconds. Whatever liquid is given, the time flow is recorded. Similarly, the time flow for water is also recorded. That means as you take out from the oven, it should come back to room temperature. After it comes back to room temperature, again using the same pipette, you should not change the viscometer nor the pipette also. The same pipette you have to use and pipette out 10 ml into the same viscometer and find out the time required by water. That you will be recording here. Okay, so this is the experimental data that you are recording after doing the experiment. Next you will be substituting and finding out the viscosity. Okay. So now this is the Poisson's equation. Using this expression, we shall be finding out the viscosity. Okay. So expansion of this is, I have expanding that, we have reduced form of this, expanded form of this. Here this is the viscosity, eta viscosity. The equation is pi r to the power 4. Pi is a constant. R is the radius, internal radius of the bulb. T is the time taken by the liquid. We have recorded the time taken. Okay. Then this D is the density of the liquid taken, because whatever liquid we have taken, it has a density and the density will be given. Okay, and this H is the height of the liquid, the capillary, height of the capillary, and G is gravity, 8 is a constant, V is the volume of the liquid taken, and L is the length of the liquid column, how much liquid is present. Okay, so taking this expression, now we have, this is a viscosity expression. Now we have recorded the time taken for two solutions. One is water and another one is we have taken for liquid. Okay. Now what I do is I will write for water and liquid separately, and then coefficient can be found out by taking the ratio. Okay. Now I am taking the ratio eta of liquid divided by eta of water. Okay. So for the same expression, the expression what I have told earlier, I have just substituted pi r to the power 4 g time flow for the liquid, density of the liquid. Okay. Now height of the let me erase this liquid. Now this is the height of the liquid column, not liquid column, it is the height of the capillary. Now 8 is a constant, V is the volume of the liquid taken, and L is the length of the liquid column. This is for liquid. Okay. Divide by water. So I have inversed it and kept here, written here 8. This is the volume of water, length of the liquid, same thing. Now this is the what coefficient. Okay. Now what I will do is I will reduce this formula. Okay, cancelling out the constants. Let us see here. See, the pi and pi will get cancelled. Gravity and G and G will get cancelled if you don't change the center of gravity. Height of the capillary will get cancelled. You have to be sure that you are using the same viscometer. If you are using the same viscometer, obviously the height of the capillary will be the same. Okay. So then is you have arc radius. Now you are using the same viscometer, obviously the radius, internal radius of the bulb will also be the same. Therefore R will also get cancelled. 8 is a constant, it also will get cancelled. L is the length of the liquid column, it will also get cancelled because you are using the same viscometer. And volume of liquid and volume of water, this will get cancelled only if you use same volume of the liquid. Okay. As you have seen, I have told you will be taking 10 ml of the liquid, and in the same pipette only you will be taking 10 ml of water. Okay. That is because it has to get cancelled. Okay. Now if you write whatever is remaining, it is only the time flow for the liquid, time flow for the density of the liquid, time flow of water, density of water into viscosity of water. Okay. If you have, by substituting our readings, we can get the viscosity of liquid. Okay. So now taking this reduced form, this is viscosity coefficient, we can find out the viscosity of the liquid provided we know these details. As we have taken water as standard, water is the one whose all parameters is known. A standard is the one whose all parameters is known. Okay. That means density, viscosity, all this is known. Okay. Now time flow for the liquid, we have done the experiment, we have recorded the time, we have done 3 trials, we have got one average. Density of the liquid we will be telling you. Then time flow for water also you have recorded. Density of water will be told, viscosity of water will be told. If you substitute all this, that is these are all given for you, density of liquid, density of water and viscosity of water. Now if you find out the time flow of water and liquid, easily you can find out the viscosity of the given liquid. Okay. So the viscosity of the given liquid will be expressed in millipoise. Millipoise is the unit of viscosity, but SI unit is kg per meter per second. Okay. So now this is the chart where we get the viscosity and density. See, now here this is water depending upon different temperature. Now we have recorded the temperature as 31. Now for 31 degrees, density of water is 0.9953, viscosity of water is 7.840. Okay. Then you will be given one organic liquid. It is now listed as 1, 2, 3, 4 like that. Whatever liquid is given to you, suppose let us assume you are given liquid 1. Okay, now you just have to see the whatever is given for liquid 1 corresponding to 31 degrees, 0.863. This is the density of the liquid. Just now we have recorded the time flow for liquid. Let us assume we have taken 61 seconds. Density of a liquid, here we went and saw in the chart, it is something 0.863. Let us assuming liquid 1. Now time flow for water, similar as liquid, we have to do and find out the time flow for water. Density of water we have recorded from, we have got it from the chart. Viscosity of water also we have got it from the chart. Now we have got the viscosity of the liquid. Okay, so this is how you find out the viscosity of a liquid, provided we need to know the lab temperature and we need to compare it to water, and we need to have the values, standard values of density and viscosity of the water and liquid at a particular temperature. Okay, so now you will be recording some viscosity, you will be reporting some viscosity for us, and the exact viscosity for that temperature is also a constant. So by finding out how much your reported viscosity value differs from the correct value, you will be awarded marks. Okay, so now we have found out the viscosity of the given liquid. Now I am just discussing on the Viva questions. Viva questions are write down the Poiseuille's equation that we have already written. What is viscosity coefficient? Viscosity coefficient, again the viscosity coefficient, you have the definition, that is viscosity coefficient can be defined as the force in newtons per meter square required to maintain a difference of velocity of 1 meter per second between two parallel layers of a liquid which are separated by 1 meter distance. Okay, so then what is the SI unit of viscosity coefficient? SI unit of viscosity coefficient is kg per meter per second. Then how does viscosity vary with the temperature? As we have experienced also, as the temperature increases, viscosity decreases. Okay, write the expression used to calculate the viscosity coefficient. That is what we have, viscosity of liquid is equal to T1 d1 by T2 d2 into viscosity of water. Okay. Why is the same volume of the water and liquid used in the determination of liquid coefficient of a liquid? Why same volume has to be used? Otherwise it will not get cancelled. Okay, and the same volume can be maintained by using the same pipette. Okay, then why acetone is used for rinsing the viscometer? Why acetone is used? Because it cleans the organic liquid. With only water you cannot clean, and organic liquid, acetone being an organic liquid which evaporates very fast, cleans effectively, and at the same time it will dry fast. Okay, so for effective cleaning and fast drying we use acetone.